I'm going to show you some examples of multiplying fractions by simplifying first. And the reason I stress simplifying first is because sometimes you work with really big numbers in your numerators and denominators. And honestly, it's easier to make a mistake when you're multiplying with big numbers than it is when you're multiplying with smaller numbers. And so this is just a really efficient way of making sure that you do your calculations correctly. Now, you can see that 9/20 is a reduced fraction as well as 2/3. But we can reduce this numerator with this denominator, and we can also reduce with this denominator and this numerator. Now, the reason we're able to do that is because if we were to rewrite this problem as one big fraction, 9 times 2 as our numerator, and 20 times 3 as our denominator, what we can do is follow the property, commutative property, that states that when you're multiplying, order doesn't matter. So in that case, we can switch these numbers around. We could say instead of 9 times 2, we could say 2 times 9. And I'll go ahead and just keep the 20 times 3, but if I wanted, I could switch the order of that as well. And the reason that's true is because 9 times 2 is 18. Well, so is 2 times 9. So order does not matter, and again, that's the commutative property, and we talked about that when we started our multiplication with whole numbers. But that's also going to be the case with fractions. Now, if I were to break these up again, I could, or I could just reduce this way, but I'm going to go ahead and just break it up, make it a little easier to see. That's going to be 2/20 times 9/3. Now you can see that the 2 and the 20 have a common factor of 2, and the 9 and the 3 have a common factor of 3. So what you could do is put a little division here, 2 divided by 2 and 20 divided by 2, and then I'll rewrite that here in a minute, but let's go ahead and divide these two terms by a common factor, which is going to be 3. Now I'm going to go ahead and just rewrite that down below. I'll have a little more room. 2 divided by 2 is 1, and 20 divided by 2 is 10. 9 divided by 3 is going to be 3, and 3 divided by 3 is 1. Now you'll notice that this was the original problem, and these numbers here are a lot smaller. It's going to be really easy to do our calculations. 1 times 3 is 3, 10 times 1 is 10. My answer is going to be 3/10. Now let me rewrite this problem because I kind of showed you the long roundabout way of how we got this answer. But let me show you a shortcut in doing something just like this. So again, I'm going to rewrite this as 9/20 times 2/3. Because I can't reduce this way or this way, you can look diagonally. Knowing that, I'm going to just divide by 2 and diagonally divide by 2, and then reduce this way diagonally. Divide by 3, divide by 3, and then I'm going to rewrite it. So 9 divided by 3 is 3, 20 divided by 2 is 10, 2 divided by 2 is 1, 3 divided by 3 is 1. Multiply across, get 3/10. Notice my answer is exactly what I got the long way, but this is kind of a shortcut way that a lot of people use, and that's okay for you to use this way. But understand that it works because of that commutative property. Let's do another one. Let's say we have 3/4, and we're going to multiply that by 12. Now, I'm going to go ahead and put the 1 underneath. Sometimes you just see it as 3/4 times 12. Make sure you change that 12 to a fraction so you can do the multiplication. Now again, 3/4, I can't do anything. That's reduced. This is improper, but the only common factor that we have here is a 1. And so let me look diagonally. Can I do some reducing diagonally? Well, the 3 and the 1, I can't. I'm not going to divide by 1, but it looks like I could divide over here. The greatest common factor between the 4 and the 12 is going to be 4. So I'm going to divide 12 by 4 and 4 by 4. Now if I rewrite that, that becomes 3 over 1. 12 divided by 4 is 3, and then I bring over that 1. And now 3 times 3 is 9, and 1 times 1 is 1. And we're going to talk in a future video. When you get something like that, you would just convert it to a whole number as 1. But if you're not sure about that, that would be acceptable for now. Let's go ahead and do a couple of fractions in which you're multiplying together. So let's say we have 2/4 times 6/10 times 5/12. Now there's a lot of terms here that we could be reducing, and let's look at them all before we decide how we're going to do it. You might have more than one way to reduce. If we just look at the numerator that's on top of the denominator for each problem, let's look at those. Now 2 and 4 have a common factor of 2, so we could divide each by 2 and reduce that fraction. 6 and 10 also have a common factor of 2. 6 divided by 2 is 3. 10 divided by 2 is 5. Now the 5 and the 12, however, cannot be reduced. Now we could also do it another way. We could do some cross reducing. Okay, we could reduce the 2 here with the 10, or you can even reduce the 2 with the 12. You could reduce the 4 with the 6, or you could reduce the 10 and the 5. So it really doesn't matter how you approach this. You know, let's go ahead and do it 2 different ways and see if we come up with the same answer. We should. So the first way, I'm going to reduce this fraction and this fraction, and then do the multiplication. So 2 and 4 can be divided by 2. 6 and 10 can also be divided by 2. And then 5 and 12 we can't. So I'm just going to rewrite and see what I get. So 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. 10 divided by 2 is 5. And then I get 5/12. Now the goal again is to simplify first to lowest terms, then multiply. It looks like we can do some more simplifying. I can reduce those 5s. So if I go here, so 5 divided by 5 and 5 divided by 5. Okay. So, and also 3 and 12. So 3 divided by 3 and 12 divided by 3. So let's rewrite that. We've got 1/2 times 1 over 1 times 1 over 4. Now it doesn't look like I can reduce anymore, so I multiply across and I get 1/8. Now let's go ahead and do it again, because I think there were some other ways we could have gone about it. Let's say we have 2/4 times 6/10 times 5/12. So if I'm going just looking at the cross reducing, let's go ahead and divide the 2 by the 2 and the, oops, I crossed that out, 10 divided by 2. And then let's divide the 4 and the 6 by 2's. Okay, so here we would have 1/2 times 3/5 times 5/12. It looks exactly where we got at this point here. So, I'm not going to do the same thing again. Basically, we could reduce these and then reduce those. Now, there is one other way that people generally like to simplify, and so let me go ahead and write one more problem on the back here to show you another way you could go about it. Say we have 8/9 and 12/16. Now sometimes people will just cross out the numbers and do the math in their head, and when you feel comfortable enough to do that, that would be okay. But if this is a new skill, I recommend not doing this until you feel more comfortable. Now I'm not going to reduce these two. I don't have a common factor other than 1. I could reduce this, or I could go diagonally. I'm going to choose to go diagonally. Now 8 and 16, so the greatest common factor between 8 and 16 is 8. So instead of saying divide by 8, I'm going to cross it out and I'm just going to write a 1, because in my head I'm doing the math. 8 divided by 8 is 1, and 16 divided by 8 is 2, so I'm going to write a 2. Now, I'll use a different color. I'm going to do some reducing with these numbers here. Now, the greatest common factor between 9 and 12 is 3. So in my head, I'm going to divide 9 by 3, which will give me 3, and 12 divided by 3 will give me 4. Now there's one more that I can do. I can reduce this 4 and this 2. 2 goes into 2 once, and 2 goes into 4 twice. So you can see I have a lot of crossing out and numbers. So this, for a new person or someone that's new at reducing, this might be very confusing, and I really only recommend doing it this way once you understand what you're dividing and what you're dividing by. Once we have our numbers, we're going to look at only the numbers that are not crossed out. So 1 times 2 is 2, 3 times 1 is 3. So we have 2/3 is our answer, is our reduced product of these two fractions.